Yuanda Valve Group has an annual output of over 30,000 tons of steel castings and can produce various chemical-type valve castings with a diameter range from DN15 to DN2000. This provides a reliable guarantee for the production of Yuanda's steel cast valves, especially chemical-type valves. The precision casting process for steel castings of Yuanda Valve Group covers 13 main technological procedures, and each procedure is of vital importance to ensure the high quality and stability of the castings. First, automatic wax injection equipment is used in conjunction with pneumatic molds to press 1:1 wax patterns required for casting production. After water cooling and shaping, the appearance of the wax patterns is manually refined to ensure a smooth surface without defects. Subsequently, the wax patterns are assembled with risers through a hot pressing process to form a tree-like structure, creating a complete gating and riser system for subsequent mold shell production. The grouped wax patterns are then immersed in refractory slurry, evenly coated, and sand is sprinkled on the surface of the slurry. They are then placed on air drying racks for air drying to improve the strength and stability of the mold shell. After air drying is completed, the wax patterns are melted by high-temperature steam, allowing them to flow out from the interior of the mold shells and be recycled, thereby obtaining complete mold shells. The duaxed mold shells must undergo high-temperature roasting to further enhance their high-temperature strength. After roasting, the red-hot mold shells are quickly moved to the furnace nozzle for molten steel pouring. At the same time, the steel materials are heated and melted in a furnace to form uniform molten steel, which is poured into the mold shells at an appropriate temperature to initially shape the castings. After pouring is completed, the mold shells are cooled to an appropriate temperature and then fed into a shell stripping machine for shell removal to eliminate the outer sand shell. The shell-stripped castings are cut to remove the feeder risers, ensuring dimensional accuracy, followed by welding repairs to fix any potential surface defects. After riser removal, heat treatment is performed. Post-heat treatment, the castings undergo fine grinding on residual risers to meet the product's contour requirements. Finally, through manual precision grinding, the castings achieve a smooth surface without defects, marking the official completion of a high-quality steel casting.